Right now, you're moving east at 1,670 kilometers per hour. If the planet stopped spinning, the air wouldn't stop with it. 85% of humanity sits in the worst possible place for what comes next. A day on Earth isn't just a number on a clock, it's the time it takes for the planet to spin once around its axis, about 23.9 hours. That spin is fast, especially at the equator, where the ground races eastward at roughly 1,670 kilometers per hour, faster than the speed of sound. Yet nobody feels that speed because everything, the land, the oceans, the air, and everyone standing on it, moves together as one giant spinning system. It's like riding a carousel. You don't feel the wind in your face unless you try to stand still while the platform keeps turning. The reason is angular momentum. Once something is spinning, it resists any sudden change. That's why the idea of Earth stopping cold belongs in thought experiments, not in real forecasts. But understanding this hidden motion is the key to what comes next. When the ground stops moving, the air above it does not. The atmosphere keeps racing eastward at the same speed it had before, about 1,670 kilometers per hour at the equator. In that instant, the air becomes a force of destruction. Near the equator, the wind would reach speeds faster than sound, entering a zone where even the strongest hurricane looks gentle by comparison. The shock wave of moving air would flatten buildings, tear apart bridges, and rip trees from the ground. Glass would shatter, steel would twist, and anything not anchored deep in the bedrock would be swept away. This is not a storm that lasts for days. The most violent winds would roar through in minutes to a few hours, as friction with the now still ground gradually slows the air. But in that short window, the damage would be total. Around 85% of the world's population lives in the latitudes most exposed to this blast. For them, survival would depend on being deep underground or in structures built to withstand forces no engineer has ever planned for. The world's oceans, unlike the solid ground beneath them, don't come to a sudden halt. Water keeps moving eastward at the same breakneck speed it had before. This isn't a gentle wave lapping at the shore, it's the entire mass of the ocean, billions of tons, surging forward with unstoppable momentum. As this enormous wall of water races toward the continents, it piles up against coastlines, overwhelming low-lying land in its path. The force is multiplied by the shape of each shoreline and the steepness of continental shelves, turning the surge into a planetary-scale tsunami. The tallest waves strike hardest where the ocean floor rises sharply, sending water hundreds of meters inland. Unlike the wind, which unleashes its fury in minutes, the ocean's surge takes hours to cross each basin. Waves wrap around the globe, colliding and reflecting, reshaping coastlines and flooding entire regions. The aftermath is not a single event, but a drawn-out disaster, as the sea seeks a new balance on a planet that no longer spins. Earth's journey around the sun continues, even if the ground no longer turns beneath our feet. But without rotation, the familiar rhythm of sunrise and sunset disappears. Instead of a quick cycle, each spot on the planet faces the sun for about 6 months straight, then plunges into darkness for the next half year. Day and night become seasons of their own. Temperatures swing wildly. Months of daylight bring unrelenting heat, while the long night invites deep cold. The thin line between the two, where the sun hangs forever at the horizon, becomes a narrow twilight zone circling the globe. For plants and animals, this change is more than a challenge. It is a fundamental rewrite of the rules of survival. Photosynthesis stalls for months in the dark, then races to catch up during the endless day. Crops, livestock, and wild ecosystems all face new extremes. Even the systems that power cities, electric grids, heating, cooling, and lighting are built around a 24-hour cycle. In a world where night lasts for months and then day refuses to end, civilization would need to rethink the very basics of time and life. Earth's shape is not a perfect sphere. The planet is wider at the equator by about 43 kilometers because the spin pushes outwards, creating what is called the Equatorial Bulge. If the rotation vanished, that bulge wouldn't snap back overnight. Instead, over centuries or even millennia, the planet's rocky mantle would slowly relax, settling into a rounder form. As this happens, water that once pooled around the equator would migrate toward the poles. Coastlines would shift as the sea creeps into higher latitudes, exposing new land near the equator and flooding areas closer to the Arctic and Antarctic circles. This slow-motion reshaping wouldn't just change maps. Deep inside, the churning motion of Earth's liquid core, responsible for our magnetic field, would lose its rhythm without the organizing force of rotation. Over thousands of years, the protective magnetic shield would likely weaken, leaving the planet more exposed to solar and cosmic radiation. The earliest moments after Earth's spin stops are the most unforgiving. Survival on the surface depends on being in places designed to withstand forces far beyond any natural disaster. Once the initial danger passes, life would not return to normal. Ordinary cities and towns would be uninhabitable. Instead, people would have to build controlled environments, underground shelters, sealed domes, or habitats shielded from the outside world. Over centuries, as the magnetic field weakens, radiation from space would become a growing threat, forcing even deeper protection. The lesson is clear. The planet's rotation is more than a background detail. It is the foundation that makes the open surface of Earth safe for life. Earth's daily spin sets the rhythm for every life and climate system we know. As we shape our planet's future, it's easy to forget. Some forces cannot be restarted.